Hello. This is the microservice test app that I will use to deploy a microservices application to a K3s local Kubernetes. So these are the configurations that I used. Here I had a gateway service which is using CPU as the trigger. We have a notification service which is also using the CPU as the trigger. We have order service. We have inventory service. So in total we have 4 services. 2 are using Prometheus and 2 are using CPU. So I deployed the application, and as you can see from these terminal logs, everything went well as expected, and the deployment was successful, as you can see here. Yeah, the deployment was successful because all the services and the autoscalers for the respective services were created. So now let's go to the terminal to see what's happening in this deployment. So as you can see here, we have I use kubectl get scaled objects in this namespace. I gave the name microservice test for the namespace that I deployed this application. As you can see, we expected 5 KEDA autoscaler 1, 2, 3, 4, 5 autoscalers. 2, we have a gateway scaled object, we have gateway service, we have inventory service, we have a notification service and order service, KEDA scaled objects, and see the minimum and the maximum ports based on the configurations that we provided in chuck.toml file. Ready, all of them are ready. Active, this is true. Active, active, active. These 3 are active because they are using CPU, and CPU always sends some metrics. So this one for Prometheus, they are false because it's below the threshold limit. Also, I inspected each of the specifications for each scaled objects, and all of them, as can be seen here, they align with what I set in the chuck.toml file. So this last showcase here, which is KEDA, which is a kubectl get HPA for this namespace called microservice test. We are using we are getting HPA because under the hood, KEDA creates a HPA, which is equivalent to HPA, that it normally uses to scale up or scale down the application. So these are the HPA objects that KEDA. As you can see, KEDA HPA, KEDA HPA, KEDA. So this HPA was created by KEDA itself under the hood. We have the one for gateway, we have the one for gateway service, we have the one for inventory service, notification service, and order service. So under the hood, this is how KEDA operates for it to scale up or scale down. So you can see the targets. This is 10 out of 50, 12 out of 50% of the CPU usage. We have 0. The target is currently we have 0 metrics out of 5. Also here we have 0 out of 3. These are for Prometheus. The ones for CPU, they are already active because CPU data or metrics are always sent. Okay, so this is the showcase of the scaled objects created by the KEDA. So the next thing, as you can see here, we have got these are the scaled objects. So now the next thing that I did now is I redeployed the application while the current one was already existing to test for dim potency when you redeploy the same application without deleting the existing one to see if everything remains the same. So here is when I redeploy the application here now. I redeployed the application, there was no any crash, everything went well. So when I now came to inspect the scaled objects here, they didn't change, it maintained its status. You can see the age 32, 32, 32, which is like which is somehow equivalent to this one is 22, 22, 22. So no new scaled objects were created. Only these ones were patched, or if there was no any changes, it just remained as it were. So you can see here we can have trigger showing you which metric is being used to scale each service. So now that is how we created a service. So let's now try to see if we try to delete all the if I destroy the deployment, let's see if there is something that remains. So let's go to VS Code and run. Let's clear it fast. Run check destroy main.chuck. Yes, we want to proceed. Let's wait for it to finish deleting. The namespace has been deleted successfully. Waiting for namespace microservice to be deleted. Let's give it some time. So everything has been successfully deleted. So let's now inspect if there are any resources that will remains. Let's say kubectl get scaled objects and see no resources found in default space. Even if we use the namespace microservice test that was there, no resources found in microservices test. So all the scaled objects that we created were successfully deleted. Let's also check deployments, if there are any deployments that remains. So kubectl get deployments for the namespace microservice test. So no resources also. Let's go to next. Try to get the services. kubectl get services. You can see there are no resources. So that was it for today. So in our next now we will now scale up and down the microservices to see if it works as intended.